Hi you guys, and welcome to today's lesson about volume of pyramids and cones. It's a little warm-up just to refresh your memory. The volume of a prism is the area of the base times the height we have right there. And then the volume of a cylinder is again the area of the base times the height, but we converted that for circles. So the area of that base is r squared and the pi, and then times the height. The only change that we have then for pyramids and cones is that the volume of pyramids are 1/3 of the prisms, and the volume of cones are 1/3 of cylinders. So if we look at the volume of pyramids, here's your formula. The volume of pyramid is 1/3 times the area of the base, just like the prism, and then times the height. We just tack on that 1/3. So 1/3 area of the base times the height. And you have your formula right here. Area of the base, remember, is always that big B, and then times the height. So we look at a couple examples right here. So find the volume of this pyramid. So the area of this base right here, so we've got, always nice to write down your formula. Area of the base times the height. So it's 1/3. The area of that base is 6 times 4, so that's 24. And then times the height, which is 9. So 1/3 of 24, 3 goes into 24 8 times, and 8 times 9 is 72. And notice the units here are inches, so we're always talking about for volume, that's units cubed, so inches cubed. Sometimes you got to read the information a little more closely about this one. It says the base is a right triangle with a right angle at point R right here. So there's a little right angle right there. So now the volume for this pyramid, 1/3. I'm going to put a little parenthesis right here. The area of this base then is the area of a triangle, which is base times height divided by 2. That one always seems to confuse students about that little area of that base. That just base times height divided by 2 for the area of this triangle down here. And then times the height of the pyramid, which is 10. Now I can do this. 2 goes into 12 6 times. 9 times 6 is 54. So we've got 1/3 times 54 times 10. And 54 divided by 3 is 18, and 18 times 10 is 180, and then this is feet cubed. So those are a couple you can try right there. I'll do this one right here just because it says now we got to read again square base. So this is 9, which means that's also 9. So 1/3 times 9, so 9 squared, which is 81, and then times 5. And 81 divided by 3 is 27. Oops. Not working. 27 times 5 is 135, and we're talking inches cubed on this one. So you can try these other two over here for a little practice. We move on to the volume of a cone, which is very similar to the volume of that pyramid. It's still 1/3 the area of the base times the height of the cone. We've just converted it again to circles. So 1/3 area of the base is r squared pi, and then times the height of the cone. So here it is in pictures. 1/3 the area of that base, the area of that circle down here, times the height of the cone. And we'll get rid of these. So I've got 1/3. The area of the base is 25 pi, because it's r squared pi, times the height of the cone, which is 6. Now I can't do 1/3 of 25, but I can do 1/3 of 6, and 3 goes into 6 twice. 2 times 25 is 50, so 50 pi, and this is meters cubed. Now be careful on this one. They give us the radius, they give us the slant height for the cone. So if we apply one of our Pythagorean triples, 5, 12, 13, I know my height for this cone is 12. So I've got 1/3 the area of that circle down there, which is, again is 25 pi, and then times the height, which is 12. Now if you get stuck, I'll show you what we can do in a later example as far as taking care of finding that missing height right there. But in this case, 3 goes into 12 4 times. 4 times 25 is 100. So 100 pi meters cubed. Again, here are 3 examples to work with. Let's go to this one first to take care of that missing side length right here, or the missing height of that cone. So I've got 1/3 the area of the circle, which is 7 squared. We'll do this 7 squared pi r squared pi times the height. Now to find the height, I've got a right triangle right here. So the Pythagorean theorem we can use is 7 squared plus my height squared is equal to 25 squared. That's 49. This is 625. If I subtract that 49 from both sides, I get h squared is equal to 576, and then the square root of that is 24. But we're hoping that your teachers have showed you the Pythagorean triples, and so we can just jump right to 24 if you remember the Pythagorean triple, 7, 24, 25. So I take my 24 and plug that in. Now in this case, obviously 7 squared is 49 times the 24. I'm going to show you 2 things we can do here. 3 goes into 24 8 times, and then 8 times 49, where'd that go? 8 times 49 is 392 pi, and then meters cubed. Now sometimes this 3 is not divisible into one of your numbers here, so what you could have done is 49 times 24, that's 1176 pi over 3. If your answer does not reduce, you can leave it like that, but we know that 1176 divided by 3 takes us back to that 392 pi. So if that 3 does not divide into either one of these 2 numbers, you can leave it as a fraction like that with the pi symbol off to the side. And we'll try one more. Remember the Pythagorean triple, 9, 12, 15. So I've got 1/3 times 9 squared, which is 81 pi for the area of my base there, the circle, times my 12. 3 goes into 12 4 times. 8 times 41 is 324 pi meters cubed again. Oop, I forgot the meters cubed down here as well. So always pay attention to what they give you, and then make sure your units, when you find the volume for those pyramids and cones, is cubed at the end.